Hi guys, welcome back to the next lesson on this course. We are doing selections today, and in selections there are a few more formulas that we need to know. We have already seen the NCR formula in details. So the NCR formula, of course, we have seen direct questions on those. So what we need to understand is that there are two more formulas with selections of identical things, and these two formulas in my list of formulas that I want you to know are I put them as 3 and 4 because, as I've already told you earlier in the introduction to this lecture, to this chapter, that we treat selections from distinct objects. Selections from distinct objects, we treat that separately from two selections from identical objects. Now, when you want to select, and the formula we have focused on till now is the NCR formula, which is, I think, 60% of this chapter, one of the 3 or 4 most important formulas in this chapter. But if you want to look at a situation where you are selecting from identical things, so let's say you are asked to select 2 things, select 2 from these 4 identical objects. The number of selections is only 1 here, because there is no variance to what you can select. So in this scenario, the number of selections is 1. Of course, if the scenario was A, B, C, D and select 2, we would use the NCR formula, because these objects from which you are selecting, are distinct. So when you select from distinct objects, you use this set of formulas. When you select from identical objects, you have to use these logics. These are not formulas, these are just logics there, right? So don't use the 4C2 formula for this situation. That would be wrong. So the third and fourth formula in this list are also commonly referred to as the sample space of selection. The sample space of selection. This is what it's commonly referred to. Now, what is the sample space of selection? The sample space of selection is a situation where, let's say, if I tell you that you have to select any number from these 3 objects, 3 distinct objects you have, and you want to select any number of objects. I'm not defining the number of objects for you. In the previous cases, I was defining the number of objects you were picking, 2 from 4, 3 from 11, those things, those kind of situations. But in this scenario, I'm giving you the freedom that you want to select any number, and if I include that you can also select 0 here, then the sample space of selections here works this way, that you have a scenario where you can select 0. Your options in this scenario are to select 0, or select 1, or select 2, or select 3. Now, selecting 0 out of 3, as we know, using the NCR formula, will be 3C0. And in permutation, combination and probabilities, ORs always mean additions. So select 1 would be 3C1, select 2 would be 3C2, select 3 would be 3C3. So the net sum of all this, through the formula, there's this formula for the sample space which says that NC0 plus NC1 plus NC2 all the way to NCN is equal to 2 raised to n. So you don't need to calculate these values individually. The sum of this is going to be 2 raised to 3. So this is the third formula. It's called the sample space of selections, and it is used wherever you need to calculate something like this. So if you have a scenario in which you are calculating 7C0 plus 7C1 plus 7C7, then the answer would straight away be 2 raised to 7. You don't need to do the calculations of each of the NCRs here, right? Now, in this is the third formula basically. And in this, if 0 is not allowed, I said in the original scenario, I said you are allowed to take 0. So if you create a situation where 0 is not allowed and you still have to select any number, then obviously there's a modification. Select 0 is not allowed, so 3C0 is not allowed. So value of NC0, as we have already seen earlier, the value of NC0 is always 1, both through the formula or through logic. So on the right hand side, you will have a -1 in the answer. So formula wise, if you are doing NC1 plus NC2, 0 is not allowed, and you have the freedom to choose any number from 1 to n, the answer becomes 2 raised to n minus 1. So this becomes the formula for selections, for the sample space of selections when 0 is not allowed. And there's a very popular question which you will see in all exams and everywhere with respect to this, and that's about the number of different values of exact change that you can pay using one coin, or using or pay if you have, let's rephrase this, the number of different values of exact change that you can pay if you have one coin each of 1 rupee, 2 rupees, 5 rupees, 10 rupee and 50 rupees. Still not very conversant in making the rupee symbol, so I guess you can understand what that is. So if you have one coin each of these 5 denominations, so how many different exact sums of money can you pay? So this question is a direct application of the fourth formula, because if you want to pay money to someone, you can pay money by choosing one coin. If you select a coin, with every selection of a coin you'll pay different amounts of money if you select one coin. Or you can also pay by selecting 2 coins. Or you can also pay by selecting 3 coins. Or you can pay money by selecting 4 coins. Or you can pay different amounts by selecting 5 coins. So what will happen is each of these will be unique. For example, 3 rupees, you can only pay using 1 and 2. Likewise, values like 7 rupees, 12 rupees, in this picture, in this scenario, you can only pay using 2 coins. Whereas values like 65 rupees, you can only pay by using 3 coins, and so on. And again, if you have to make a payment of 68 rupees, you can only do it by using all the 5 coins. So essentially, needless to say, this answer, the number of different values of exact change that you can pay in this scenario, this answer will be 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5, and this value will be 2 raised to 5 minus 1, because it's a standard value there, right? It's the direct application of this formula. So this is a question you should know, because it is asked very commonly, very often. And PNC in general, permutation combination in general, you can actually take an approach that once you do your first 150-200 questions on this chapter, you will be done with everything that can be asked in this chapter, right? And you can take this approach in this chapter, that you memorize all the questions that you have done. You will be able to solve 80 to 90% of the questions that will be asked in exams, in your placement exams or any other aptitude exams you care to take, right? So I hope you enjoyed this solution, and I will do the tougher question on NCR in the next lesson. But before I wind up this one, let me also tell you the 5th and 6th formulas. It's not formulas actually, it's just a logic that if you are looking at sample space of outcomes if you are faced with identical objects, so with 4 identical objects, again you can select 0 or select 1 or select 2 or select 3 if you are given the choice of selecting any number including 0. So you can select any one between 0 to 4. But in this case, the values will not be NC0 and NC1, or for that matter, in this case, the values will not be 4C0 and 4C1 or 4C2. Those will not be the values, because selecting 2 from this sample space, from this selection space, is not 4C2. And as we have already seen, in this scenario, for each case, you will have only one option. What you choose will get defined by only one way of choosing. And hence, if you have 4 identical objects, you have 5 ways of choosing if you are allowed to choose any number. So in general, this formula can just be n plus 1, and if 0 is not allowed, of course it will become n. But these two formulas you don't need to bother about too much, because they are not asked on. You will not find a single question on it. Formula 4, on the other hand, 0 not allowed, had that change question that I discussed with you. So formula wise, these are the 6 formulas of NCR of selections. 3 for distinct objects and 3 for identical objects. So I'll come back to you in the next lesson with more questions on NCR. And I personally believe that if you have understood NCR well, then most of this chapter actually goes, difficulty level actually goes downhill from there. So make sure that you are understanding what I'm saying right now. If required, watch it a couple of times, because I know a lot of you have this problem in this chapter. But it's one of the easiest chapters to actually master once you understand how to read the question and look at the logic. Fine. It's very few chapters in maths where I can actually tell you that you can actually memorize the questions. This is a chapter where you can do that. So I'll wind up with this, and I'll see you on the other side with the next lesson in this chapter. Bye for now.